Hi guys, so in this video we're going to show that in fact WP is a metric. So to do that we need what's called the gluing lemma. And to do this we're going to take three spaces and three probability measures. And yeah, so I is 1, 2, and 3. And we're going to let pi 1, 2 and pi 2, 3 be couplings of mu1 and mu2 and mu2 and mu3 respectively. Then there is a probability measure on x1 cross x2 cross x3 such that pi of x1 cross a cross b is pi 1, 2 of a cross b, and pi of, no, this is 2, 3, sorry. Pi of a cross b cross x3 is pi 1, 2 of a cross b. So this is for every a cross b in the Borel sets of x2 cross x3 for all a cross b. And so for simplicity, this is a basis, typical basis set of the Borel sigma algebra, but then you can build the whole measure from there. So that's the gluing lemma and our real proposition. So just keep this in mind. We won't prove this here. Proposition is that WP is a distance. Our proof, I'll leave symmetry and WP of mu is 0 to u. And then we'll pick up where WP of mu and nu equals 0 to show that mu equals nu. So I'm going to let D be the diagonal. So this proof can be seen in Villani's, I forget the title of it. I think it's chapter 7 in his first one. But he's had different versions of the same book on optimal transport. So this is for x and x. We're on probability space x. Then D restricted to D is 0. So if this is equal to 0, then our optimal transport map, this actually tells us that x, we don't have to consider D because we know the distance is 0 here. So there's an optimal map pi such that D of xy to the p, d pi of x. I'm outside of the screen. Yeah, okay. Such that the optimal transport map pi is equal to this. We don't have to consider D because the distance is 0 on D. So what this really tells us is that pi of a minus D is 0 for all a that is a Borel set of x cross x. So what this tells us is that for every phi and CB of x cross x, sorry, this is CB of x cross x, the integral of phi of x d mu of x is equal to the integral over x d nu of x times the integral. Let's call this y. Call this x tilde. Phi of x d mu of x. So this is, because this is equal to 1, right? Because nu is a probability measure. This is equal to, so this is just Fubini'S theorem, right? So this is Fubini. Phi of x d mu of x d nu of x tilde. But then this is just phi of x d pi of x dx tilde, because pi is a transport plan. And then similarly, the integral of phi of x tilde d nu of x tilde is also equal to phi of x tilde d pi of x and x tilde. That's the same as right, because these are just dummy variables. And so what that tells you then is that, okay, so let's just rewrite this really quick just to make sure the point is clear here. So this is the integral over x d mu of x. And then remember, this is just a dummy variable. So I can relabel x tilde as x. So this is phi of x d nu of x over x. And this is for every continuous function. Oh, sorry, this is supposed to be on x. Yeah. So, sorry, I ran out of space on this page. That might run over a bit. I'll rewrite that over here. Integral of phi of x d mu of x over x d nu of x. That tells us that, so this is for every, phi was arbitrary. So that tells us that mu equals nu. So we're good there. So now all that remains is the triangle inequality. So, and we're going to use, this is where we're going to use the gluing lemma, remember? So I'll go back over here just to review. So the gluing lemma is going to tell us that if we have pi 1, 2 and pi 2, 3, that we can create a new measure on the triple cross product of the three that has marginals that basically fit what we want them to be. So it glues you because notice that the second variable here, that's the one that is in everything. It glues you through x2, you glue x1 to x3 is basically why it's called the gluing lemma. I'm going to switch colors here for no reason. Just getting bored with the blue here. So we're going to go to red. So what we want is we want mu1, mu2, and mu3. And notice that x1 is x2 is x3 is just x in all these cases. So, and we want to show WP of mu1 and mu3 less than or equal to question mark. We don't know this yet. Mu1, mu2 plus WP, mu2, mu3. right? So WP, so what we're going to do is we're going to say let pi 1, 2, pi 2, 3 be optimal transport plans from mu1 to mu2 between these two and mu2 and mu3 respectively. Okay, and let pi be as in the gluing lemma. Okay, and then we'll define pi 1, 3 of A cross B to be equal to pi of A cross X. So remember, this is where we're gluing. We're gluing through X2. That's the sense that gluing is being used here. So we're going to take the whole space X, and that's how we're going to glue A and B. So note that pi 1, 3 is a coupling of mu1 and mu3, and I'll leave that to you guys. WP, and now we're just ready to crank through inequalities here. So WP, right, we don't know if pi 1, 3 is optimal, so this is less than or equal to the integral of dxy. We'll call it x, let's call it x1, x3 for convenience here. But remember, this is on x cross x, right? So this is d pi 1, 3 of xy, because it's a coupling. We don't know if it's optimal. To the p to the 1 over p power. Okay. And then we'll do the same trick. We'll multiply by 1. And then use the fact that the marginals work out. This is x cross x cross x, dx1, x3 to the p, d pi, oh, sorry, x1, x2, x3 here, d pi, dx1, x3. So all we've done is we added an integral over another coordinate x2, where x2 is really the space x. We've now introduced that variable, and since the marginals work out properly according to this definition, those are equal. It's like multiplying by 1. So now this will be less than dx1 x2 plus dx2 x3 all to the power p. And that's just your regular triangle inequality. Okay. Now, okay, so let's this is really so if we call this g, this function g, this is really like well, okay, let's call it g1 plus g2. This is g1 plus g2 LP of x with respect to pi, and that's your space. I'll just keep it as LP for now. We know that LP is G1, G2 LP. So that's all that's going on there. So this is going to be equal to or less than or equal to, sorry, d of x1, x2 to the p d pi x1, x3 to the 1 over p plus dx2, x3, x2, x3 to the 1 over p. That's to the p. Okay, and I hope you see where I'm going. So now I'm going to do the same thing. I'm going to pull x3 out of this one, and I'm going to pull, x1. I'm going to pull x1 out of this one. So this will be x cross x, dx1, x2 to the p, d pi 1, 2, x1, x2, d pi 2, 3, x2, x3 to the 1 over p. Now remember that these are optimal. Those are optimal transport plans. So this is precisely equal to WP. And same here. Both of these are optimal transport plans. And so we have now shown that WP is, in fact, a metric. And that completes the proof.